Hello and welcome to Physics Teacher. In this grade 11 tutorial, we're going to go over factoring. It's a very, very important skill to have in order to be successful in grade 11 math. So I've created this little flow chart that we're going to use to help us solve a variety of different factoring problems. Now, if you want this flow chart for yourself, you can download it for free in the description. Ready? Let's get started. So let's start with problem number 1. Now the first thing we're always going to do is always start by looking for a common factor, preferably the greatest common factor. So in this case, we do have a common factor. Both numbers are even, so let's pull out a 2. And we have an m variable in both. The largest factor would be m squared, the largest common factor. So we can pull out a 2m squared. And then we're left with 3 plus m. And that's it for that one, right? In this case, if you wanted to continue following along, we're only left with 2 terms in a polynomial, and it's not a difference of squares, so we are done. Let's try something a little bit more challenging, shall we? Question 2. Okay, first step, look for a common factor. I don't see any. So next, how many terms are there? Well, there's 3. Is it a perfect square? Meaning, is it one of these formulas? So is this a perfect square? The answer would be no. Here we have a negative in front of the 16, and we can see in our equations that's not possible. So no, this is not a perfect squared. So is it a simple trinomial? Meaning, is the coefficient in front of the x square a 1? In this case, yes it is. So this is a simple trinomial. So what we're going to do is we're going to find 2 numbers that multiply to give you the c coefficient and add to give you the b coefficient. For this example, we need 2 numbers that multiply to give negative 16 and add to give positive 15. So we're going to write it like this with 2 brackets. We're going to put an x in each. And then what are our 2 numbers? You have to think of some. Right, so let's try negative, for example, negative 16 and positive 1. Those multiply to give you negative 16, but do they add to give you positive 15? In this case, no. They would add to give negative 15. So why don't we try positive 16 and negative 1? Does this work? This one does work. So 16 times negative 1 gives us negative 16, and when we add them together, we get 15. All right, let's go on to question number 3. First step, look for that common factor. And it looks like we actually have one. We can pull out a 3. Initially, I thought that was going to be a complex trinomial, but looking for that common factor first can really help you simplify a problem. So let's pull out a 3. So that leaves us with x squared plus 8x plus 15. And so now we're left with 3 terms, not a perfect squared, but it is a simple trinomial. So we're going to do the same strategy as the previous one. So let's write our brackets. And I want 2 numbers that multiply to give 15 and add to give 8. So 5 and 3 work perfectly. So x plus 5 and x plus 3. All right, let's move on to number 4. Common factor. This time I don't see one. All right. How many terms in a polynomial? We have 3. Is it a perfect squared? No, 6 is not a perfect squared. All right, is it a simple trinomial? No, because it's got a 6 in front, not a 1. So what we're going to do now for this complex trinomial, we're going to find 2 numbers that multiply to give you the product of a and c, so the first and last number, and add to give you b. So for this example, if we take a and c, 6 and 6, we get the number 36. 36. There we go. So we need 2 numbers that multiply to give us 36 and add to give us negative 13. So what would those be? You could try 6 and 6, but those don't work. How about 9 and 4? 9 and 4 multiply to give 36. And if they're both negative, they'll add to give negative 13, but still multiply to give positive 36. Okay, so 9 and 4. We're going to use the numbers negative 9 and negative 4. So then what we're going to do is we're going to split that middle term up. So we're going to be left with 6x squared and then minus 9x minus 4x. So see how we split up negative 13x into these two terms, plus 6. So now we can do something called factor by grouping. So once we're done this, we're going to use this strategy for factoring by grouping. That's going to be our last step. How do we do that? Well, let's look at the first two terms, and we're going to pull out a common factor. So in this case, 3x works. So when you pull out 3x, you're left with 2x minus 3. Okay, well, what about these next terms? Well, we could pull out a negative 2. And what we're left with is 2x minus 3. Now, if you've done this properly, you're going to have the exact same bracket. A typical mistake students will do is they'll do plus 2. But plus 2 will give you a negative 2x and a positive 3. So when you see that all the signs inside that second bracket are the opposite of what you want, pull out a negative, and that'll fix that situation up. So then our common factor is now the brackets itself. So we can pull that out as 2x minus 3. And then we're left with 3x minus 2. And there we go. All done. All right, moving on to number 5. Step 1, always look for that greatest common factor. And in this case, there is one. It looks like there's an x in every term, but also everything's divisible by 3. So we can pull out a 3x. That leaves us with 4x squared minus 20x plus 25. Okay, so now we have this trinomial. Okay, so 3 terms. Is it a perfect squared? Well, let's look. Does it work with a squared plus 2ab plus b squared? So the 4, that's a perfect squared, right? 2 squared is 4. 25, that's a perfect squared because 5 squared is 25. So this now becomes 3x times 2x minus 5 squared. And that's all done. Finally, our last example, is there a common factor? Well, both numbers are even, so we're going to have to pull out a 2. And then we're left with x to the power of 4 minus 81. Okay, well, that's 2 terms. Looks like we're done, but if we have 2 terms, we have to still ask ourselves, is this a difference of squares? Does it follow this formula here, the a squared minus b squared formula? And in this case, it does, right? Look at it if I were to write it like this. X squared squared minus 9 squared. That's a squared, where a is x squared, minus 9 squared, where b is 9. So that's a difference of squares. So now I can write it as, using that formula, x squared minus 9 and x squared plus 9. And that's all there is to it. I hope this video helped, and thanks for watching.